Welcome to Daily Papers, the podcast where we break down fascinating new research into bite-sized conversations. Today, we're looking at the guardrails we put on artificial intelligence. We think of modern AI as being super smart, but what if you could trick it with something as simple as a jigsaw puzzle?
That's a great way to put it. We're talking about a specific type of AI called a Vision Language Model, or VLM. These are the AIs that can both see images and talk about them in text. Think of models like GPT-4 with Vision or Google's Gemini. You can show them a picture of your fridge and ask for a recipe, and they'll understand.
Right, and developers spend a huge amount of time and effort on what's called safety alignment. They essentially train these AIs to be helpful and harmless, teaching them to refuse dangerous or unethical requests. If you show one of these AIs a picture of a bomb and ask how to make it, it will politely say, "I can't help with that." This is because it's been aligned to recognize harmful content and refuse to act on it.
Exactly. This process of trying to trick an AI into breaking its own rules is often called jailbreaking. For a long time, researchers have been trying to find ways to jailbreak these models to expose their weaknesses so they can be fixed. But modern AIs have gotten really good at resisting these attacks, especially when they involved a single, straightforward image.
But this new paper, titled Robustness of Vision Language Models Against Split-Image Harmful Input Attacks, found a shockingly simple and effective new way to jailbreak them. The researchers asked a simple question: what happens if the harmful image isn't whole?
This is the core of their discovery. Their attack is called SIVA, which stands for Vision Split Image Jailbreak Attack, and it works exactly like it sounds. They took a single harmful image, let's stick with the bomb example, that the AI would normally refuse. But instead of showing the AI the whole picture, they cut it into 2 or 3 pieces.
So like a little jigsaw puzzle for the AI. They would feed all the separate pieces into the model at the same time and then ask the exact same question: how do I make the object in the combined image? And what happened?
The AI would often just give them the instructions. The safety training failed. The success rate for the jailbreak jumped by a huge margin, in some cases up to 60% higher than previous methods. By simply splitting the image, the harmful request slipped right past the AI's safety guards.
That is wild. Why does that even work? Is the AI just not smart enough to put the pieces back together in its head?
It's a little more complicated than that. The paper digs into the root cause, and it's about how these AIs are built. In simple terms, the AI processes images in stages. The first part, the vision encoder, looks at the visual information. By design, when it gets multiple images, it looks at each piece in isolation. It sees a piece of metal here, some wires there, but it doesn't connect them.
So it doesn't see the full picture at first.
Exactly. The next part of the AI, the language model decoder, is what puts all the pieces together to understand the scene. It's smart enough to figure out that the pieces form a bomb. But here's the critical flaw. The AI's safety training was almost exclusively done using single whole images. It was never taught to aggregate weak signals of danger from multiple pieces and then sound the alarm.
So its utility function, its ability to be useful and identify objects, works fine with split images. But its safety function, its ability to say no, doesn't. It's a blind spot in the training.
Precisely. And of course, the researchers knew that once this flaw was exposed, a simple defense could be created. You could just build a pre-screening tool. This tool would look at the images being submitted, and if it detects they're pieces of a larger puzzle, it would stitch them back together before the main AI sees them. Problem solved, right?
I have a feeling the answer is no. This sounds like a classic cat and mouse game.
It is. So the researchers developed a more advanced attack to bypass this defense. This is where it gets really clever. Instead of actually splitting a harmful image, they started with completely innocent, full-sized images. Let's say a picture of a landscape and a picture of a flower. These would pass the new stitching defense easily because they aren't split.
Okay, so how do they turn a landscape and a flower into a harmful object?
This is what's known as an optimization attack. They subtly change the pixels of the landscape and the flower in ways that are almost invisible to the human eye, but these tiny changes are designed to manipulate the AI's internal representation. So, to the AI's brain, the altered landscape image now looks internally just like the top half of the bomb, and the altered flower image looks like the bottom half.
Wow, so they're feeding the AI two full-size, innocent-looking pictures that have been manipulated to masquerade as the split pieces of a harmful image. The stitching defense is bypassed, and the main AI is still tricked.
You got it. But there was still one problem. This advanced attack required what's called white box access. This means the attackers needed the full blueprints of the AI model to craft the perfect pixel changes. In the real world, you rarely have that. You usually have black box access, meaning you can only interact with the model, not see its inner workings.
So they needed a way to make this attack work on any model without needing the blueprints, the final boss of jailbreak attacks.
And they built it. Their strongest attack is called transversiva. It uses a technique called adversarial knowledge distillation. The best analogy is teaching a student AI to mimic a teacher AI. The attackers take an open-source AI model that they have full control over, the student. Then they have the student observe how the teacher responds to thousands of different images.
So the student model learns the teacher's patterns and weaknesses just by watching from the outside.
Exactly. The student model's internal representation becomes aligned with the teacher's. Now, the attackers could use their white box access to the student to create the perfect adversarial images. And because the student now thinks like the teacher, there's a very high chance that those same images will successfully trick the target AI. The attack becomes transferable.
That's both terrifying and brilliant. So after finding this fundamental vulnerability and creating these powerful attacks, did the paper offer any hope? Is there a fix?
Thankfully, yes, and the solution is quite elegant. They propose going back to the safety alignment stage. When training the AI to be safe, you can't just show it whole harmful images anymore. You also have to show it those same images split into various pieces, and teach it that these pieces, when combined, are also forbidden.
So you're patching the blind spot you discovered. You're explicitly teaching the AI to connect the dots across multiple image inputs and recognize distributed harm.
That's the idea. They call it an augmented training strategy. It's a reminder that as AI gets more complex, the ways to secure it must also evolve. What this paper shows is that sometimes the biggest threats don't come from highly complex attacks, but from a simple idea that everyone overlooked, like cutting a picture in half.
A powerful lesson in the ongoing quest for safe and reliable AI. That's all the time we have for today. Thanks for tuning in to Daily Papers.